I want to give you a quick explanation of the Doppler effect so maybe you can understand it without just the definition, understand what's behind it and better be able to describe it. So this is an example and we'll use it to talk about that. So I've got a car, and we'll assume it's a police car, and it's traveling to the right, and it has its siren on. And the sound of the siren is described by this wave. And there's a driver in the car, okay? And this would be the sound he would hear because he's moving with the car. There are two observers, observer 2 in front of the car and observer 1 behind the car. The observers are standing on a sidewalk and they're stationary. So the car and the siren are moving relative to these two observers, observer 1 and observer 2. So the definition for Doppler effect is it's the change in frequency and wavelength of a sound when the source of the sound is moving relative to the observer. So for the effect to occur, you need a moving source of the sound. And that's the key, okay? So we've got this car, it's moving forward, moving to the right. You've got observer 2. Here's the wave that's being created by the siren, okay? So if you notice what's happening in front of the car is that as the car is moving, the wavelet that the siren is creating, or the sound that the siren is creating, the frequency of it, you notice that the wavelength is getting shorter. Okay, so the wavelength is decreased in front of the sound. Okay, and so in a way you could say it's sort of being compressed or it's being squashed. Okay, so in front of the sound, the wavelength is shorter. Okay, now if the wavelength is shorter, since the velocity of sound here, Vs, is a constant, right, in the air, we'll assume that, depending on the temperature, okay? But at a given temperature, it's a constant if it's air. So the wavelength is shorter. That means the frequency has to be higher, okay? Okay? That means the frequency has to be higher since the velocity is basically constant. Okay? If the frequency of the sound is higher, okay, in front of the car as the car moves toward this observer, then that means if the frequency is higher, then the pitch of the siren is going to be higher. Okay? So if you're observer 2 and you're listening to the siren, the pitch you hear, the apparent pitch you hear of the car coming toward you, the pitch of the siren is going to be higher than the pitch that the driver hears by virtue of the fact that the car is traveling toward you. Okay? Now, if you're observer 1 behind the car, okay, then in this case, the wave emitted by the siren is going to be expanded. It's going to be extended, okay? It's not going to be collapsed. It's going to be extended. So you notice the wavelength behind the car is greater than the actual sound, okay? So back here, if the wavelength is longer, then since the speed of sound in air at a given temperature is basically a constant, then that means the frequency has to be lower. And if the frequency is lower, then the pitch of the sound will be lower also. Okay? So the apparent pitch that the observer 1 hears is going to be lower than the actual siren, and the pitch that observer 2 hears is going to be higher than the actual siren. Okay? Now, there's one other thing I want to talk about and add on to this, and that's it. And it's not mentioned in the definition below, but as the car approaches observer 2, okay, the amplitude of the sound is going to increase. Remember, waves convey energy. Okay, they convey energy. And that energy is lost as the wave travels through the environment, through the air. Okay? And and so what's happening is the closer the car is to the observer, the higher the amplitude. So as it moves closer, okay, as the car moves closer, okay, the amplitude is going to increase, okay? And if the amplitude increases as the car moves closer, then the loudness of the siren will increase, okay? And in the opposite way, as the car moves away from observer one, the amplitude is going to decrease. This is observer one. The amplitude is going to decrease. And the loudness of the siren is going to also decrease. Okay, so one thing to keep in mind here, frequency is pitch in common terms. Amplitude is loudness in common terms.